Okay, so now we're going to look at a systematic sample. Okay, systematics, just assume there's a system attached to it. And what we're doing here is we're using our sampling frame or a list or whatever to help us take a regular interval of people. So say again we've got our kind of parent population of 200 and we want a random sample of 20, which is basically every 10th person. We just need to generate where we're starting between 1 and 10 and then take every 10th person from there. Okay, depending, it doesn't matter how the list is organized, we're just doing it in the same jump each time. And the one thing we need to do is make sure that we just randomize where we start. Okay, so that's what I think I've put here in the description. The sample is selected from a randomly generated starting point and then at fixed periodic intervals. So how we do it is you number the population, or your population is numbered you have information that already kind of lists your population in some way, gives you a sampling frame. You work out what the interval jumps need to be by taking how many things are in the population and divide it by your sample size. So in the case I had before, there were 200 members of the population and I wanted a sample size of 20. So I was doing 200 divided by 20, which gave me 10. So I want every 10th object, and then all I have to do is use random numbers to decide where to start. Okay. Now, if I've got 199 things and I want a sample of 20, well, I can still take every 10th thing, but I might generate my starting point to be between 1 and 9. Okay. So it's a kind of it's not always going to go exactly. Your total number of items in your population divided by your sample size isn't going to go exactly necessarily. You're going to round down maybe, depending. It kind of does depend on the example what you can do about it. Okay, but what is important is you randomly generate your starting point. You just don't start from the first one. Okay. It doesn't give you a truly random sample. Although if your list is randomly ordered, it does help make it fairly random. And therefore, because it's systematic, it could introduce bias. If you had an alphabetically ordered list of students, it could preclude your chances of being, if the heavily weighted number of surnames beginning with B, and it's alphabetically ordered your list, then the people in the B section are going to have less likely to be selected, aren't they? Okay. Although you'll get a representation of them, not everybody in there is equally likely to be chosen, whereas, towards the end they might be. So the thing about a systematic sample, it's easy to use, and one of the times that you'll use it is for trying to get a large sample. I think I'm just checking a minute. So if say we wanted a sample from college, we could get all the student numbers, make sure which ones are being used. Okay, so it's suitable for large samples and large populations, I think. Just add that bit in. So if you've got a large population, it's all numbered and you're taking every 10th one, you know precisely which ones you want. Okay, the idea is the sampling frame helps you kind of build that up. It doesn't have to be alphabetically ordered. It could be by date of birth. It might be by tutor group. It's however it's ordered. It could just be a list of everybody who's enrolled in college randomized in some way. Okay. So systematic sampling is usually, every third person on a particularly given list is an easy way of doing it. All right. So now we have an example of that. Understand? Oh my goodness, we're in Old Trafford yet again. Okay, the seats are numbered from 1 to 1400. Describe how a systematic sample of 50 people sitting in these seats could be obtained. Well, our first thing is we could number the seats. It's probably easier if we number the seats, really. They are numbered already, right? Okay. So here it's 1 to 1400. Now we need to work out what our jump needs to be. So 2, our interval, is going to equal 1400, that's how many there are, divided by 50, which is 28. So on every 28th item. Now 3, our starting point. We're going to randomly generate a number between 1 and 28. And then take every 28th. So if we randomly generate a number and it comes out as 19, then we would take the 19th one and then add 28 onto that and take that one. I mean, if there happen to be nice rows of length 28, then we'd take the 19th person and then it would be the same person sitting all the way up, every 19th one from then on. Okay? And that's how you do it. So for a random sample, we generate random numbers all the way through and ignoring repeats. For a systematic sample, we have assigned numbers again. We work out what the interval would have to be for us to be able to get to every person. And then the only random part is where we start. Okay? So that is systematic sampling.